All right, ladies and gentlemen, we are looking at 2.6. We are finding how to prove statements about segments, and we're going to prove using a two-column proof, not a paragraph proof for these. We remember reflexive, symmetric, and transitive for last time. So let's go ahead and look at our first proof here. Okay, so we have a picture of two segments, AB and CD. We are given that AB is congruent to CD, and we want to prove that CD is congruent to AB. What do you think we're going to use here? What do you think we're going to use here? Some symmetric, yep. We've got our statements and our reasons. So everybody's got these already on their paper. So we're going to look. First thing that you've got to write down is the what? What always comes first? Given. AB is congruent to CD. Oh my goodness. Sometimes my board is crazy. CD, and this is given. I like to list them like 1, 2, 3, just so I can keep track of what I'm doing. I really need you to pay lots of attention to this because your quiz is based on this, and this is brand new stuff. Okay, number 2. Watch what I'm doing. How does this look different if I say AB equals CD? I didn't say they're congruent. I took the segment off the top. When we do this, we call this definition of congruency. And that means we can either take away the congruency symbol and just make it equals, or put it in. Step 3. CD equals AB. What did I do right there? Not reflexive, it's symmetric. And finally, what do I have to do for step 4? How does this step 3 look different than what I'm proving? It's got what? What's that little symbol right there? Congruent. So we're going to put the lines back on top, and we're going to put the congruency symbol back. And what do we call that again when we do that? Definition of congruency. Definition of congruency. It's when we take away the congruent symbol or we put it back. How do we feel about that so far?
Pretty simple.
Pretty simple one? Okay. Let's look at the next one. I'm just going to move it up.
What's number 2 there again? Definition of what?
Congruency. It looks like a Z because my computer keeps connecting. Definition of congruency. Okay. All right. The next one, I'm given lines. I have R, S, and T, and I have W, X, and Y. All right. I am given that RS equals XY and ST equals WX. And I'm going to prove that RT equals WY. I've got my statements. I've got my reasons. Okay, from the comic, oh, silly thing. From the comic book thing that we just did, what were the comics? Were they the statements or the reasons? Statements. What was the thing that we wrote? It was the? What is the first thing I always write in my statements? The given. What is right up here? RS equals XY. ST equals WX. That's my given. I strongly suggest that when you're given the given, you draw on your diagram if you're given one, so it makes sense. RS is congruent to XY, and ST is congruent to WX. Okay, that's going to really help you out. Okay, what do you think I'm going to have to do up here? I want to prove that the whole things are congruent to each other. And we have that the pieces are congruent to each other. What do you think we're going to have to do? And what kind of things are they? So we're probably going to have to use segment addition. You guys, I know this isn't the most exciting thing all the time in the world, but I really need you to stay awake for this. Your quiz on Friday is just like this. We're going to be using proofs all year. So my first step here is, actually I'm going to use something before that. I'm going to use the addition property. We could have put segment addition first, but all I'm doing, do you guys agree that RS and WX are the same? Do we also agree that ST and XY are the same? So I'm adding the same things on. All right, step 3. I'm going to use that segment addition. I'm going to say RS equals RS plus ST. Sorry, it's split up, guys. This is segment addition. Okay, what else do I have to have up here? I've got one segment addition. Can somebody tell me what they think the other one would be? What would the other segment addition be? What would the other segment addition be? We've got one segment. What would the other one be? Quentin, wake up. So this is what? WX plus equals, okay, there we go, guys, come on. WY equals WX plus XY, and that, again, is my segment addition. Okay? So finally, since I have this and these are equal to each other, that means I can set the whole thing equally to each other by what? RS is equal to WY by what? I took this out and I put this in. What is it? Substitution. How are you feeling about that? So-so? Did I make a mistake, Mr. Van Hersen?
RS equal RS plus ST should be RT?
RT, yes, thank you. This should be RT, and this should be RT. Oh. Guys, I make too many mistakes. You gotta catch me. Yes, Jacob.
For number 2.
Yes.
When you underlined it, ST and XY in green, what did that mean? They were congruent?
Yes.
ST and
WX are congruent, and RS and XY are congruent. So, you know, if I've got an apple plus an orange, it means the same thing as an orange plus an apple. That's what that's saying. Since, see how it says RS equals XY up here? RS equals XY. So they're the same thing. And I'm adding the same thing, ST and WX, to it. You good? That's a great question. Anybody else before we try the next one? Okay, the next one's a little bit long. Are you ready? No. All right. We've got AC equals 91. We've got A, B, C. And we've got A to B is x minus 10. And B to C is 4x plus 1. That's the one you have on your sheet, right? Okay. Example 3 for the first page. Yes. Okay. So, I want to solve for the variable. So, the end will look like what? What am I trying to prove? X equals something. And I'm given all that information. So the first thing I'm going to do is I'm going to make my statements and reasons. Okay. The first thing I'm always going to write down is the what? Given. Well, I know that the reasons over here is going to look like given. What I might have trouble with is the statements, because I'm not given a statement, I'm just given those pictures. So what do I have up here? I know this, right? AC equals 91. What else am I given up there? Very nice. AB equals x minus 10. What else? Good, guys. Okay. What do I want to give first? What do I have up here? Do I have an angle? Do I have a circle? What do I have?
Segment.
Okay. I know what the whole thing is, and I have an idea for what the parts are. So what do you think I'm going to use? What kind of addition? Segment addition. I'm going to say that AC equals AB plus BC. And this is segment addition. I want you to notice, ladies and gentlemen, that I didn't skip right to the letters. You know, I had to actually state out. Okay. What do I want to do now? I've got, yes, very nice. I want to do substitution. So instead of AC, what am I going to put? 91 equals AB is, okay, and BC is? Very nice. And that's substitution. You guys are doing great with me. Do you feel pretty confident you can do this on your own? Not yet. We'll get there. We'll get there. What am I going to do now? Combine like terms. Very nice. So I'm going to have 91 equals x and 4x gives me 5x. And negative 10 plus 1 gives me negative 9. And we say this is combine like terms. Okay, what do I do next? Add 9 to both sides. So 91 plus 9 is 100. Somebody's checking my math right in case I make a mistake. Okay, what do I do now? Divide. So I get 20 equals x. Do I have x equals something yet?
No.
What do I have to do? My last step, step number 7.
Symmetric.
Symmetric, flip it. I'm sorry, Liana. Step 5 is add. That looks crazy. Thank you. I was trying to shorten it for you guys so you had less to write, but then it looked crazy. Okay. We're going to stop right here, and we're going to do the rest tomorrow. Along with, I'm going to give you some proofs to try on your own. I do believe you have enough information to try your homework. You should be able to try every single problem with something, and we will go over them tomorrow. All right? I would like you to get out your writing.